Okay, so we should be recording now. So this is the recording for what's today's date? 9/16 for yes, Wednesday 9/16 for our Math 104 meeting time. Okay, so Kajina asks, can we do number 11, please? Sure, we can do number 11. Before we get to number 11, again, just reiterating for anybody who came in late, I handed back all the first quizzes. So if you didn't receive a quiz, if you didn't receive an email from me last night, it's because I didn't receive your quiz. So please double check with me. Make sure that, if you didn't get anything back, it's because I haven't received anything. So come talk to me about that. But otherwise, for as far as the grades are concerned for the first quiz, overwhelmingly you guys did great. There were like a whole bunch of 10s, a lot of 9s. No one failed. I think the lowest grade was a 7 out of 10, if my memory serves correctly. So great job with it. And if you do have any questions as far as my handwriting or as far as the grade that you received, please feel free to reach out. But again, great job on the first quiz. And let me also do you guys the favor of letting you know. So for the next quiz, which will be on Friday, so this upcoming Friday, that the material is going to stretch all the way as far back as the roots and the rational exponents, so the fractional exponents, because we technically never that got pushed back as a result of the move out date. So that material you haven't been quizzed on yet. So expect one question on that. In general, my quizzes are 2 or 3 questions. So expect one quiz specifically on either roots or rational exponents. So if you forgot those, if you don't remember the rules or such, go back to that lecture and make sure that you really hammer that into you. Practice the homeworks again if it still doesn't make sense. So expect one question on that, and then the other 2 topics that will be on the quiz on Friday will be solving a linear equation and solving a quadratic, because that's obviously what we're covering now. Okay. All right. So number 11. Number 11 says show whether or not r is equal to 2 minus square root of 3 is a solution to x squared. And, oops, writing in red. That's from last night. X squared minus 4x plus 1 is equal to 0. Okay, so it's asking us to show whether or not the r, and I'll write this as well, 2 minus square root of 3, is a solution. What does that mean? Essentially, what that means is that when you're going through the process of solving through a quadratic, you will end up with solutions, right? And for a quadratic, you will at most end up with 2 solutions, right? So all this is asking you is just do a check. Just plug in r into your x and see, hey, will this work out? Will I get 0 is equal to 0? So all you're doing is you're just going to plug in 2 minus square root of 3 for wherever that you have an x and check out the math. And if it works out, then great. R is a solution to your quadratic equation. And if it doesn't work out, and if you get some other number other than 0 on the left-hand side, then that means that R is not a solution to your quadratic equation. So that's exactly what we're going to do. We're going to plug in the 2 minus square root of 3 everywhere that there's an x. So we have 2 minus square root of 3 squared minus 4 times 2 minus square root of 3 plus 1 is equal to 0. Okay, so let's do the middle piece first, because the middle piece is a little easier to conceptualize. Okay, so obviously we're going to have the equal 0 here. We're going to still have the plus 1. We're bringing that down. Okay, so let me see. Amanda, can you help me out? How do I distribute the negative 4 to the middle piece? Just keep in mind that everybody's muted off the rip. Okay, somebody else can help me out with this? How do I distribute my negative 4?
The first thing you do is get negative 8, right?
Yeah, right, because we're going to distribute the negative 4 to the 2. Perfect, Jack. Okay. And then negative 4 distributed to the negative square root of 3. What is that going to give us?
12. I mean, right? You just multiply it?
So careful, right? We're going to multiply it, sure, but that 3 is under a radical, right? And we can't multiply numbers unless they're both under a radical. Like, well, I'm sorry, we can't make that 4 times 3 unless they were both under a radical, right? So what we're going to do is it's just going to be 4 times the square root of 3. And then what's my sign? Because I have a negative times a negative.
So it would be positive.
Positive. Perfect. Thanks, Jack. Okay, so we have the -8. We have that plus 4 square root of 3. Okay, so Grace, I think that was Grace H. Could be wrong, but I saw the hand go up. Try to help me out with the first piece now. So I have 2 minus square root of 3 squared. Now, you can either FOIL this, or you can apply the a minus b squared blueprint. Whichever way, helps you remember it. Which way do you want to go with this?
The a minus b squared.
A minus b squared. Okay, so I'm going to write this off here so that we're all familiar with this. Remember our blueprint, a minus b squared. And Grace, go ahead. What's this going to come out to be? Just our blueprint.
Sorry, I was muted. It's in parentheses, a plus b, and then close parentheses, open another bracket, not bracket, parentheses, and then a minus b. So I guess in this case it would be, sorry, you're asking for the actual numbers. 2 minus.
Careful. I just want to make sure that I heard you right. Did you say this? A squared minus b squared?
Oh my god, I didn't know.
No. I didn't hear what you said. Sorry, that was my fault. So can you just reiterate what our blueprint's going to come out to be?
Oh, I thought it was going to be like parentheses, a plus b, close parentheses, and then open another set of parentheses, a minus b.
This one right there?
Yeah.
Okay, so close. This one is for difference of squares, right? This one is for if we have a squared minus b squared. But close. That is one of the ones that we did discuss. So what this one comes out to be is, and it's going to look very, very similar to this one, and I'll write out this one. So if we have a plus b squared, we get a squared plus 2ab plus b squared, right? Now, the only difference between a plus b squared and a minus b squared is if we, is that, the sign, right? And all that sign influences is the middle piece, that 2ab. So we would come out to be with a squared minus 2ab plus b squared. So this is the blueprint that we want for today because we have something minus something inside of, the quantity being squared, right? So if we have a squared minus 2ab plus b squared, my a is going to be the 2. We have the minus, and my b is going to be the square root of 3, right? So Grace, if you could just continue with me here. So what is a squared?
It's going to be 2 squared, so 4.
Yep. So we get 4. Perfect. Okay. What is my middle piece, that minus 2ab? So it's going to be minus 2 times a. You already told us is 2. What's b?
Negative radical 3, or negative.
Okay.
Sorry,
No. That's okay. So I'm happy that you said negative. And the reason that I'm happy that you said negative is this is a really big misconception when people see this at first, right? So it's actually just going to be positive square root of 3. And the reason that it's positive is because part of our blueprint says that we're already taking into account this negative sign here, right? Which means that we're already taking into account this negative sign here, and that negative is what's making this entire thing negative, the minus 2ab. So we don't actually have to put another negative because that's going to flip the sign of the whole middle piece. So it's just the positive square root of 3 that we're going to bring down here.
Okay, gotcha.
Okay. And then b squared is the square root of 3 squared, and square root of 3 squared means that we're just going to cancel out that square root, and we're just going to get the plus 3, right? So right now what we have is 4 minus 2 times square root of 3 plus 3 minus 8 plus 4 times square root of 3 plus 1. Okay, so we have a lot of simplifications that we have to do. And Amanda, yeah, I see your message. That's fine. So let's see. Who can I call on to help me simplify? Gianna, help me out here. How do I multiply? What's 2 times 2?
2 is 4.
4, great. And then 4 times square root of 3, can we simplify that anymore? Or do I just leave it as 4 times square root of 3?
You just leave it.
Great. So we're going to have minus 4 square root of 3. And then we bring down the plus 3, the minus 8, the other 4 times square root of 3 plus 1 is equal to 0. Okay, so Gianna, I'm still on you here. Help me cross some stuff out here. I have a minus 4 square root of 3 and a plus 4 square root of 3. What's going to happen to these?
You just cancel them out.
Great. Okay. And then what's going to happen with my 4, the plus 3, the minus 8, and the 1?
You just add them all together.
Great. So what's 4 plus 3?
4 plus 3 is 7.
Great. 7 minus 8 plus 1 is equal to 0. What's 7 minus 8?
7 minus 8 is -1.
Great. Plus 1 is equal to 0. Yay, 0 is equal to 0. And now you just say, great, I got 0 is equal to 0. R is a solution. And we're done.
I have a question.
Sure.
So I used a quadratic formula and I just plugged in the numbers from the original equation.
Okay.
And would I be able to do that?
So, okay, so 2 things. One, the quadratic formula is something that we will cover in today's lecture. So the one that I'm going to post today. So basically, yes, that would work. But you jump the gun a little bit because the whole point of this is you're supposed to use the resources that you currently have, right?
Yeah.
So what we talked about. But yeah, that would be going forward. That's a totally acceptable way to check that that's your solution. But the whole point is that we're supposed to take, okay, in the question they said that this was or maybe is not a solution, and we just have to check by plugging in. And for 99% of the time when you're doing a check, what you're really doing is you're plugging in the value that you got back into your original equation. So that's all we were doing here. But yeah, that's an acceptable way to do it as long as you didn't use the quadratic formula originally. So say I'm just making something up here. Say you used something else that we're going to discuss in a lecture today, which is called completing the square. So say you completed the square, you factored, whatnot, and you ended up with your solution of 2 minus square root of 3, and you wanted to use a different method to double check your answer. That's absolutely fine.
Okay, thank you.
Yep. Sure thing. Okay, so Deborah's asking for 24, sure thing. I think we only had 5 homework questions today, so should be pretty light. Okay, so 24 is 2x squared is equal to 50. And I said go ahead and solve both 24 and 28 by the square root methods. And square root methods, I put that, the S there, because technically there is technically 2, which is you could either square root first, or you could, put it into the standard form and use difference of squares. And both are considered the square root method. So, Deborah, since this is your question, do you have any insight on what our first step here is going to be? How did you want to approach this? Do you want to put this in standard form? Did you want to just try to look at the operations tied to our variable? How do you want to go with this? Okay, so what I'm going to do here is I guess I'll show you okay. So what I'll do is I'll show you both ways just so you guys can see that it is totally solvable either way that you wanted to do it. Okay, so I guess the first way that you could do this is you can take my advice from the lecture and you could divide out a number that's going to evenly go into everything. Why would you do that? Because again, it makes your life easier. And I showed you guys in the lecture that it doesn't necessarily matter whether or not you divide out, like 2 or 3. As long as it goes into everything evenly, it's definitely possible to do that, right? So I'm going to first put this into standard notation. So I'm going to say, okay, I have 2x squared, and standard format for a quadratic is where we have 0 on one of the sides, right? So I'm going to subtract the 50 over, and now we have 2x squared minus 50 is equal to 0. It's now in standard form. Okay, and now again, remember I told you guys you can go ahead and divide out by a number if it makes your life easier, right? So the number that I'm going to divide out by is 2, because 2 goes into 2, 2 goes into 50, and I can divide 0 by any number, and it'll still be 0. I'm not changing anything, right? So I divide everything by 2, and we get x squared minus 25 is equal to 0. Okay, Deborah, what do you see here? I have a square. I have a subtraction. And now you have to ask yourself, what can I do with 25? Is 25 a perfect square? And even if it wasn't a perfect square, could we still, drop it into our formula?
Yeah, you can square it.
Okay, so we could square root it, right? And then what is the square root of 25? 25 is the same thing as 5 squared, right? So this is essentially x squared minus 5 squared is equal to 0. And now, great, we have a difference of squares. So Deborah, help me factor the difference of squares.
X minus 5, x plus 5.
Perfect, right? A minus b times a plus b. Great job. Okay, and we carry that equals 0 down. And now, by our zero product property, we can split this up into two different linear equations. So we have the x minus 5 is equal to 0, x plus 5 is equal to 0. And we solve for x. We get x is equal to 5 here, and x is equal to negative 5 here. I added 5 on the left, I subtracted 5 on the right, and that means that our solution set for x is just plus or minus 5. Does that make sense? So all we did was we made our life easier by dividing out the 2, because the 2 was problematic. It was annoying us. And then when we did that, we realized, oh, great, we have a square, we have a minus, we have another square. We could just, go ahead and live our lives with the difference of squares formula. And then once we did, we factored into x minus 5 times x plus 5 and solved for each. Okay, so that was one method that you could do. And there's a slight variation of that where if you didn't divide out by 2, this would still work out. It would just be a little bit messier. But I'm not going to show you guys that because I think intuitively, once you realize that you can divide out the 2, this makes a lot more sense. But the other method here is, so we started with 2x squared is equal to 50, right? Okay, so instead of moving the 50 over into, making it the standard form, what I want to do is I just want to try to brute force solve for my variable. The reason that I want to do that is because I only have an x squared, right? I don't have plus some other, 3x or, negative 7x. I don't have anything like that. I just have one single instance of my variable. So what I'm going to do is I'm going to still start with dividing by 2. So if I divide both sides by 2, we know we're going to have x squared is equal to 25. And remember, when we have the square, we can undo a square with a square root, right? So what that means is I'm going to take the square root of both sides. Taking the square root of x squared, that means that the square and the square root are going to cancel out. So I just have x, which is exactly what we wanted. And taking the square root of 25, we get 5. But remember, when we're taking the square root of a number and we're solving for a variable, it's always plus or minus. The reason is because we want to include both different solutions for x, right? The square root of 25, when we're talking about just the principal value, is just 5. Principal, you think positive, it's only 5. But when we're solving for a variable, we have to take into account all the possible numbers that would satisfy the equation. So we always put a plus or minus for a square root when we're solving for a variable. So we get x is equal to plus or minus 5, and that's the exact solution set that we had before, right? So either way would totally work out. Whichever way that you guys saw when you were at home working on this, totally fine. Okay? Hopefully that makes sense. Any questions on that? Okay. So what other questions you guys have? Again, that was 2 of them. There should be 3 more that maybe we could ask on if you have problems with them. I imagine that 28 was probably also a little bit tricky. So if somebody wants to go over that, I can definitely do that.
We can do 28.
Sounds good. 28 it is. Okay, so we have 2x minus 3 squared is equal to 25. And then 18 after? Okay, Grace, you got it. Okay, so 2x minus 3 squared is equal to 25. So based off of exactly what I just showed you guys might think to yourselves, oh, well, this is now substantially easier because we could just apply the exact same thing that we did in the last example. And what we did in the last example is we could just say, oh, Well, I have my one instance of my variable being squared, right? There's only one x that we see. If we had, for example, I just want to write this out hypothetically, I'll use green for this. If we had 2x minus 3 squared plus x is equal to 25, the method that I'm about to do won't work. And the reason for that is because when you're taking the square root of both sides, if you did this, you would be taking the square root of everything, including the plus x, which wouldn't be able to cancel nicely, right? So this wouldn't work. But because we just have that one single parentheses, one single instance of our variable, what we can do is we can take the square root of both sides. So we take the square root of both sides, and we say, great, what's going to happen? Well, easy with the left side, right? Square roots, going to cancel with the square. We end up with 2x minus 3. And now, based off of exactly what I said before, with the last example, what is my right side going to be? Taylor, what's the square root of 25 when we're solving for a variable?
5.
Okay, so remember it's 5, but we're solving for a variable, right? So what goes in front of the 5?
Plus or minus.
Plus or minus, perfect, right? Because we're taking into account both of the different solutions, both of the things that square root of 25 could give us, right? Because 5 times 5 is 25, and also negative 5 times negative 5 is 25. So you can see that both of them squared give us 25. So we have plus or minus 5, right? Okay, so now all we have to do is just continue our normal operations, but now it's a lot easier because we just have a linear equation, right? We just have 2x minus 3. The trick for solving it this way, when you have the plus or minus 5, it's just keeping that plus or minus all the way down until the end, and that'll give you two different solutions depending on whether or not you're adding 5 or subtracting 5. So we have 2x, and what I'm going to do is I'm going to add 3 to both sides, right? So adding 3 to both sides, we now have 3 plus or minus 5. And now my last step, the only last operation that's tied to my x is the 2. So I'm just going to divide both sides out by 2, and we get x is equal to 3 plus or minus 5 all over 2. And now you can see here that depending on the operation that we choose, it's going to give us two different solutions. The first, and I'll draw them out like this. So the first is if we had x is equal to 3 plus 5 over 2. Well, 3 plus 5 over 2, that's 8 over 2, and 8 over 2 is 4, right? Okay, and now moving over here, if we consider subtraction instead, we have x is equal to 3 minus 5 over 2. 3 minus 5 gives us negative 2 over 2. So I'll write that one out, negative 2 over 2. And negative 2 over 2 is just negative 1. So now we end up with our solution set being negative 1, 4. And these are the two different solutions that we can get. So this was one way that you could have approached it. It's totally fine if you wanted to do it the other way. So the other way, just to get you started if you wanted to, is if we had, so again, 2x minus 3 squared is equal to 25. What you could do is you could move the 25 over because you want to get it in standard form, and then you could apply the difference of squares formula that we're, constantly referencing, right? So moving it over, we would have 2x plus 3 squared minus 25 is equal to 0. And now you realize to yourself, great, we have a square, we have a minus, and we already discussed that 25 is really the same thing as 5 squared, right? So we have a difference of squares. It doesn't matter that we have a bunch of terms inside of our parentheses being squared. You can consider this whole big thing in parentheses as your a, and then your the 5 squared, or the 5 in this case, would be your b. So you have a squared minus b squared. And obviously this is still equal to 0, right? And what this means for you is that you're going to apply a plus b times a minus b. That's how you factor difference of squares. So we know that we're going to have something like this is equal to 0, where we have a plus and we have a minus. And the b should be easy because you know the b is just going to be 5. And you ask yourself, well, what is my a? A, again, is going to be everything that is inside of the parentheses because that entire quantity is being squared. So this is going to be 2x plus 3 plus 5, and then 2x plus 3 minus 5. And then we can simplify and get 2x plus 8, and then 2x minus 2 is equal to 0. And now this part should be relatively straightforward. I think that everybody here can solve this, right? You break it up into its linear components, you solve for x in each case, and you'll end up getting 4 and -1, and so it matches either way. So whichever way you found was easier, totally fine. I personally find that just taking the square root whenever possible makes life a little simpler, but that's just me. Okay? Any questions on that? Because I know that this can be a little bit of a tricky concept when you're considering, like, when we're used to seeing a squared minus b squared, we're always used to a being just one particular number. We're used to it being like, I don't know, 7 squared, and then you have like 4 squared, for example, right? The trick here is that it doesn't necessarily matter how many terms you're bundling inside of A. As long as that whole thing is being squared, you can still apply the difference of squares formula. Okay, so hopefully that makes sense. Okay, so Grace asked for 18. So with 18, we are trying to solve specifically by factoring. Okay, so we have x squared minus 5x plus 3 is equal to -1. Okay, so with factoring, we don't have any freedom as far as whether or not we can be in standard form. As you guys can see, when we're dealing with squares with like entire quantities being squared, we sometimes have the liberty of keeping it out of standard form because we can take the square root of both sides and then solve for x, as long as you keep the plus or minus in the back of your head, right? Because again, when you take the square root of both sides and you're solving for a variable, the side that doesn't have your variable should have a plus or minus. But with factoring, we have to have it set equal to 0, so that way when it is factored, we can use the zero product property. So let's see, who haven't I called on today? Okay, Kayla, help me out. So I want to get it in standard form. So what's my first step to getting in standard form?
I'm sorry. Hold on a second.
I didn't hear what you said. So what we're trying to do is we're just trying to get this in standard form. So that's where one side is equal to 0. So what's my first step in doing so? Okay, so in doing so, we have to get 0 on one of the sides. So because I have a -1 on the right-hand side, I'm just going to add 1 to both sides, right? So adding 1, we get x squared minus 5x, and then we get 3 plus 1, which just gives us 4, right? And great, now we have a 0 on the right-hand side, which is exactly what we're looking for. Now this is in standard form. We have a quadratic is equal to 0. Great, it's a quadratic equation. Okay, so now all we have to do is kind of don't worry about that equals 0. We're just worried about factoring. And how do we factor? So Grace H, this was your question. So help me factor here. I have x squared minus 5x plus 4. We have a coefficient of 1, right? So we don't need to do that secret step of a times c. So we just need to look at factors of c, which in this case is 4. So help me think about factors of 4. What are my factors?
1 and 4 and 2 and 2.
2 and 2, right? And then 1 and 4, just like you said, it's a positive 4, right? That's a plus sign. It's a positive 4, so that means our signs have to match, right? Either 2 positives or 2 negatives. So plus or minus, plus or minus, plus or minus, plus or minus. And our goal is we're looking for a factor pair that when added together gives us a -5. So what are my two numbers going to be?
Wouldn't it be like -1 and -4?
Great. -1, -4. This is exactly what we're looking for, right? Because -1 plus -4 is the same thing as -1 minus 4, which is -5. Great. So we know then that we could split this up into our two parentheses, right? And we always know that when our coefficient is 1 for x squared, that we can just start with our x here and our x here, and then we just fill in with our factors. So now we have x minus 1 and x minus 4. And we just drop down that equals 0 because it's still part of an equation. Okay, and then from here, we just do our normal break it into the linear components. So now we have x minus 1 is equal to 0, and x minus 4 is equal to 0. Great. Finish this up for me, Grace.
So x is going to equal 1 and 4. X will equal 4.
Perfect. So our solution set is then just 1 and 4. Okay, 1, 4. Yay, and we're done. That's it. Okay. So the last question is 19, which just for the sake of it, we'll go through that as well, because again, it's very similar, but just want to make sure that you guys have a very firm understanding of what you're supposed to do when it says solve by factoring. I should also state that for the record, on quizzes or on midterms, 90% of the time, except for possibly this Friday. So I would say actually every time except for maybe this Friday, I wouldn't tell you a particular method to use. The only reason I'm going to tell you a particular method to use possibly on this Friday is because we only have 2 methods. So I might say, use this one or use the other one. But going forward, of the 4 different methods that you could use for solving quadratics, I'm not going to be picky. So if, the factoring makes sense to you, great, use factoring. If quadratic formula, when we get to it, makes sense to you, then fantastic, use a quadratic formula. But just for the sake of this homework, it says solve this by factoring, so that's what we're going to do. So we have x squared plus 5x is equal to 14. Okay, so now we're going to switch to Grace P. Help me out. What's my first step here? We have to solve by factoring, so our first thing is we have to get into standard form, right? Help me help me do that.
Do you have to move the 14 over? Negative.
You do. Fantastic. So subtract 14 from both sides. Read out what my thing is going to end up looking like.
X squared plus 5x minus 14 equals 0.
Perfect. Great job. Okay, so x squared plus 5x minus 14 is equal to 0. Okay, that's perfect. So now moving down along, we have a coefficient of 1 for x squared. So that means that we don't need to do that a times c step, right? Because we would end up with just the same thing of just looking at negative 14. So we're going to look at the factors of negative 14. All right, so Grace P, help me one more time. What are my factors of negative 14 that I can just jot down here?
1 and 14, 2 and 7.
1, 14, 2, and 7, right? And because this is a negative 14, that means that the signs would have to be flipped. We know we need at least one negative. So we're going to have plus or minus 1, minus plus 14, plus or minus 2, minus plus 7, right? Okay, so now what we're trying to do is we're trying to pick the factor pair such that they would add together to give us plus 5, right? We're always looking so that we pick factors that would give us the middle term here, positive 5. Okay, so we look and we say, great, positive 7, negative 2, those look good, because if we have 7 plus a negative 2, that's the same thing as 7 minus 2. So 7 minus 2 gives us a positive 5, exactly what we want. So we want these guys. And then we carry down that equals 0. We know that we're going to have our 2 factor pairs. We know that they're both going to start with x because we had an x squared with no coefficient, with a coefficient of 1. And then we just plug in our 2 factors that we found, right? So we had the positive 7, we had the negative 2, and then just solving this, x plus 7 is equal to 0, x minus 2 is equal to 0. We get x is equal to negative 7, and x is equal to 2, and that's my solution set. So negative 7, 2. Okay, so that was the whole homework. Kajina's asking for the classwork question number 2. That's great. I would love to do that. I don't remember what the classwork question number 2 is. So if you could help me, I would be more than happy to write that out.
It's parentheses x minus 3 close parentheses squared equals 4.
Okay, so this x minus 3 quantity being squared is equal to 4. Okay, so this one is going to resemble number 28, the last question on our homework. So we have some quantity with our variable being squared, and it's equal to a constant. It's equal to some other number. So you can approach this in 3 different ways, if I recall. I think the first way is you could expand this. You could then move the 4 over to get it into the standard form, and then you could try refactoring it, and you would end up with your factor pairs, because I think this does factor nicely. But the way that I'm going to approach this is just with our 2 different square root methods, right? So the most obvious one is we have an x minus 3 quantity being squared. I just want to get rid of that square, right? So I'm going to take the square root of both sides. Taking the square root of both sides, we know that, again, the square is going to cancel with the square root as we wanted. So we have x minus 3 is equal to, and we know that the square root of 4 is 2, but it's not just 2 because we're solving for a variable, right? We're part of an equation. We're solving for a variable. So when we take the square root of our other side, it's plus or minus 2. Don't forget the plus or minus, because otherwise you'll only end up with one solution. So we have plus or minus 2. And now we just have this linear equation, right? We have x minus 3 is equal to, whatever. So what we're going to do is we're just going to undo that subtraction with addition. So we add 3 to both sides. We get x is equal to 3 plus or minus 2. And that's going to break up into, whether you have 3 plus 2 or 3 minus 2, right? So x is equal to 3 plus 2. X is equal to 3 minus 2. And we know that that's just going to give us 5. That's going to give us 1. So our solution set, when we're all said and done, is just 1 and 5. Okay, so that's one way to approach this. The next way that we can approach it, and I'm just going to save time and just clear it. The next way that we can approach this is we know that we had a quantity squared, right? And because we have a positive 4 on the right-hand side, if we put this into standard form, we're going to have a subtraction of 4 on the left-hand side, right? So if we, move the 4 over, and we have x minus 3 squared, we move the 4 over, we have minus 4 is equal to 0. Now you say to yourself, okay, great, we have some quantity being squared. We have a difference, and we know that any constant we can turn into essentially, a square, right? So the square 4 is essentially the same thing as 2 squared. So, and I'll write that up above just so it's really obvious. So we have a difference of squares, right? We have some quantity minus being squared minus another quantity which is squared. Okay, so if x minus 3, this whole thing is my a, I have a squared minus b squared, where 2 is my b. So now we're just going to use difference of squares. And we're going to say, okay, well, we know we're going to end up with a plus b times a minus b. So it's just about plugging in. So a plus b and a minus b. B, we know, is 2, right? That was the whole point of bringing the 4 over. So we know that we're going to have a 2 here and a 2 here. And now our a is just that entire quantity inside the parentheses being squared. Our x minus 3 is a. So we have x minus 3 plus 2 and x minus 3 minus 2. And this gives us, again, it's still equal to 0, still part of an equation. And now all we have left to do is just split this up. You could simplify first. That's totally fine. If you wanted to simplify first, this is x minus 3 plus 2, so x minus 1. And x minus 3 minus 2, which makes it more negative. So x minus 5 is equal to 0. And now this looks totally way more friendly, right? So now we break it up. We get x minus 1 is equal to 0. X minus 5 is equal to 0. And we know that our solution set, again, is just going to be 1, 5. Do you have questions on that, Kajina, or anybody for that matter? I only said Kajina because you were the one who brought it up.
Yeah, no, it's fine.
Make sense? Okay.
Yeah.
Great. Any other questions today? I know the homework was kind of light, so, I didn't expect it to take up the whole class period. But if you do have questions, even if it's from a previous homework, totally acceptable. I just want to make sure that we're all okay with factoring, because factoring is very important, and that we're all also okay with recognizing that just because you have an entire quantity being squared, just because, it's not just one number being squared, doesn't mean that you can't substitute it in for your A, right? Or for your B for that matter. So we still have this whole thing, x minus 3. We can just plug in for our A because it's x minus 3 quantity being squared. Okay. Okay, so unless we have another question here at the buzzer, I think we can call it for a day. Be on the lookout for your the next lecture that's going to be up. It's going to be more on quadratics. It's going to be the last two different methods that we can use to solve a quadratic. One of them is going to be called completing the square. The other one is called the quadratic formula, which was already referenced today. And the homework will be tied specifically to those as well. So the homework for today was tied to factoring and square roots. The homework for tonight is going to be tied to completing the square and using the quadratic formula. And then again, for Friday, be prepared for at least one question on roots or, rational exponents. I don't want you guys to forget that because I know we covered that, like that lecture was posted on Friday of last week. So just have it fresh in your memory for going into this Friday. Okay. So otherwise, yeah, you guys can go ahead. We'll end about 10 minutes early today and enjoy the rest of your day. Oh, and again, last thing, if I didn't receive a quiz from you, if you didn't get a quiz back from me, please email me. All right, that's it. Have a good one, guys.
Thank you. Thank you.